Hello everyone, welcome to my YouTube channel. It's my newly created YouTube channel. It's got 0 subscribers. But if you enjoy my content and subsequent content that I'll be posting in this channel, please do subscribe and like the videos, comment, positive or negative. What is it called? Constructive criticism is welcomed here. Okay. So what I'll be doing is I'm trying to create an educational channel where I get to, if I learn something, I then get to apply it in much more practical way of learning it, right? So instead of just learning the theory behind whatever concept or no concept that just came out in the tech world, I get to implement it that way. I learn best because even though I may not be applying it now, but later on, because I've done it before, that muscle memory as well as my knowledge, it will still be it will still be there. So that would be the whole purpose of this channel. So this is my first ever video. I've been thinking about it for a very long time, and I've been delaying creating this channel because I always thought, okay, look, I need to prepare. I need to down procrastination. So now what I'm just going to be doing is I'll just do this stuff. I learn as I make more videos. I get to learn and improve the presentation of my videos, how I speak and so forth. So what we'll be doing is learning the concepts of software development or software engineering, if you may say, that are quite important as a software developer to know, right? So I'm talking about like the patterns that are available out there, like CQRS, domain-driven design, microservices, etc., etc., etc. So we'll be implementing an example, which is a chess game. So the end goal of this chess game, but it will be in series of videos. We'll have a user interface as well as a chess game server, which is going to be an API that manages the session of, let's say, 2 users playing chess against each other. Yes, I know it's been done before, but I like to do things, start it from scratch on my own, just so I learn how to do it. It may not be because I'm going to build a chess game for some company somewhere. No, it's just learning the concepts behind software development. So, and I chose to use the chess game as an example. I've built a chess game before. I was still in varsity back then. Did it as an assignment, but I did it in C++, and it was a Windows Forms application. Right now, Windows Forms applications, it's not a thing anymore. So a lot of let's say companies or like whatever, they require like websites, and the websites can be built using different tools, platforms, or whatever you want to call it. Things like React, Vue, Knockout, but Knockout it's out of it's no longer supported anymore. But I'm just using it as an example. There's Microsoft MVC, Razor, etc., etc., etc. So as we go along with this video as well, but for this one, it's just going to be an API, which is going to be a chess game server API, right? So, but the end goal is 2 users. As you know, in a chess game, 2 users get to play chess against each other, and whoever wins, right? And as they are playing the chess game, they take turns, right? So the first order of business, right? When we're building a bigger system, so like imagine this is like a big project, and let's say we're delivering it like in sprints, like 2-week sprints. So our 2-week sprint for now, it would be a chess server that can accept 2 players and take turns. That's it, right? And then on the next video, we'll build on top of that, like adding, let's say maybe the board, the pieces, the rules behind the pieces, the rules of the chessboard, detect checkmates, all the other stuff that will come as we go along with the other videos. But for now, for this one, we're just going to build a chess game server that will again accept 2 players, and each player must be able to take a turn, like when they play, right? So enough with the talking, let's just jump right into it, right? So I'll be using our source control that I'll be using is my a GitHub. I have a page on GitHub, which is github.com/Luanilemfunis. And there's this other name over here that you see, Chess Game Server, is just the name of the repository, which will be the repository we're working on for this particular channel. So yeah, enough with the talking. Let's just jump into it. Okay. First order in doing so is we want to copy this link. This link we'll use in Visual Studio to send our code into this page. So I'm just going to copy this and head over to my Visual Studio. And over here, I want to create a new project. So open Visual Studio and then say create a new project. Take your time, Visual Studio. And then we want to build like a blank solution. And the blank solution, let's just name it Chess Game Server, right? Chess Game Server. And then I want to store it on a folder which I called for recording, because it's solely for when I'm recording videos like this. And by the way, this example I'm building here, that I'm doing a tutorial for, I've pre-built it already. So you will see, as like right now, my setup is I have two screens, one screen and the other one over here. So the full solution that I'm going to be implementing is going to be on this side. So I'll be taking the stuff and put it on this side, but I'll explain the concepts behind it as we go along. So so I named it Chess Game Server, create. And there we have it. Now, another thing that I like to do for like whenever I'm building like a new project is the first initial check-in is a blank solution. You don't have to do it, but it's just my preference. So I just want to go over to changes, and then I want to say create a Git repository. But I don't want to create a new one because we already created that page on GitHub. So I'm just going to choose existing repository. Hopefully that, okay, it's still on my thingy. So, and then that link I showed you on the previous page, which is this one. I pasted on my existing repository. Now, when I say create and push, what it will do is it will take my blank solution and put it on my GitHub on my GitHub page. Okay, now let's just save. We'll put whatever comments you wanna put. So I'm just gonna say save init. I just say save init. Okay, it looks like it pushed automatically. Okay, let's go ahead on our GitHub page and see. Now what I want to do is I want to refresh this. Let's see. Nice. Here's our solution. Our solution is there. So next thing, what I want to do is, so as I mentioned, that we're building an API. Actually, it's a server which would be an API, right? So in C#, what we can do is on the solution, we can add a new project, which is going to be a web API, and I'm going to call it Chess Game Server dot let's say API. Let's just keep things simple. Let me say API, right? I'm going to choose .NET 9 because that's the latest as I'm doing this video. Take your time, Visual Studio, take your time. And by the way, coding is quite fun. I don't know about you, but for me, it's quite fun. It's quite fun. Oh, okay. Now let's go back. Not go back, but now I want to add two more projects again. So which is going to be the domain. So I'm just going to create a library for this one. It's going to be library, and I'll call it Chess Game Server dot. It's going to be the domain. So this library is going to house our domain model for our chess game. Right now also supports .NET 9. And then now we need to go ahead and create another, which is a final one, which will be responsible for storing anything to do with persistence, because we're going to be storing, see the anything like our entities on our chess game, we're going to store it in a database. So now we'll have a layer for database, which is called Chess Game server dot say persistence. Hold on. Persistence. So this will house our persistence layer. It's .NET 9. Yes. Cool. Then go ahead and I want to delete these default classes. Default classes. The weather forecast, I don't need you. That's just an example. I don't need you. Just gamesaver.api, I don't need that. And the controller, I don't need this controller. That's the default controller that's added by Visual Studio when you create a new API, right? Just to make sure everything is okay, I rebuild. And hopefully the solution, well, actually it should build because there's nothing already. It should build. We're done? Oh, still building. Still building because I can tell with this thing. You're taking time. It's just 3 libraries. Come on. Nice. So another thing I want to do is I want to make sure that persistence is going to be for any objects that we're going to be creating over here. So domain must be referenced inside persistence. So I'm just going to go say, come on. Let's add, it's a project reference. Where is that thing? Project reference, which is that. Okay, and then also on the API, I'll reference both of the 2 projects that I just created, which is a project reference, both the domain as well as the chess domain. Okay. Now, another thing, which is, it's been a common pattern for me, is let's say you were tasked to do this initially, but you didn't have a framework. Like connecting to the database, you would have to write all of that code up front. But for me, I have packages, which I should do a video explaining those packages available, which are stored on NuGet, right? So those packages, they house a framework for me so that I don't have to repeat that logic of how to connect to a database. The only responsibility now or thought, okay, wait, let me fix this. I just saw something here. That H is a capital. I should just say, yeah. Why are you red? Why are you red? I don't like that. I don't like it. Let's see. Okay, just to not have problems up front, I'll delete it and edit again. Sorry, let me just do this quick. Yes, game. Just game domain. This directory is not empty. Come on, what are you talking about now? Nice. Cool. Delete. And also make sure this references this. Cool. Now, next part is I want to add on each of these libraries the project references or the NuGet packages that I'll be using to implement the solution, right? I've done this, remember, I've done this before. So now just to make the video a little bit short, now I'll just copy and paste this stuff because I don't want to make like 5-hour videos because I know it's quite boring to watch a 5-hour long video. So these are the packages I'll be using: into the framework core, into the framework core design, SQL Server tools, SQL Server and tools and configuration. Okay, and then on the domain side, we'll use these packages. Right, Xframe is a framework that I've been writing to write common code that I get to use on multiple projects, right? And the nice thing about using this is, or following this pattern, is, imagine if we have a big system like a microservice that has about 10 services, right? And if each API or a service, if you may call it, it's implemented in the same way, which is by the packages. All 10 of them, you know how they actually work in, like, technically. The only thing you would have to focus yourself on is like the business logic of that particular API, right? And if you don't understand what I'm talking about, go and have a read about like what microservices are, and get to understand what it means to have a service. So, and then what I'm talking about here now, it would actually make much more sense. And also, I'd like to explain that we're not going to be talking in detail about, okay, like what's a microservice. No, we're not going to do that, because now it's going to make the video quite long. But now, what we're going to be doing is we're going to be focusing on building the chess game. Actually, let me just put it this way. We'll be focusing on building the business rules or the requirements of how to build a chess game server, right? We're not going to focus too much on the technicalities. So we'll be using X-Frame, which has common functionality, technical functionality on how to implement services or microservices. Okay. And then also, let's go over for the API. On the API side, we have, which is this guy. I don't need open API, but I'll delete, so it's fine. Or actually, I can even delete it from here. Right, so we'll use AutoMapper, Newtonsoft JSON, anti-framework code design. I'll explain this when we get to the persistence side. When we get to build the persistence, why do I need this entity framework code design? It will make much more sense when I'm doing it practically. Right, and we also need ASP.NET Core, which is Swagger, Swashbuckle. This is Swagger. This is used for documenting my APIs. Okay, cool. Now we get to the nitty and gritty stuff, right? So now what we want to do is we want to first start off building the domain model, right? Domain model for this project. Domain model for this project would be, let's see, domain model, right? A domain model, it would house an aggregate. If you don't know what an aggregate is, feel free. There's not actually too much, but I love the Microsoft documentation. It's much more clear. There is a documentation available on Microsoft website where it gets to explain the concepts of DDD, which is domain-driven design. That's where the concept of aggregate comes from. So we would have aggregate. And then on our aggregate, we want to build a chess game session, or what do we call it? Let's call it chess game session. A chess game session is what is a chess game session would be the engine of the chess, which will control how many players do we have, who are these players, whose turn is it to play the game, and it will also keep the state of the game, right? But remember, we're not going to put everything as we're building here. The whole purpose of this one is to build a chess game server that functions, that accepts 2 players, and each player can take a turn. That's it. That's what we're going to do, right? And then the other stuff, as I said previously, we'll add as we go along. So we'll add our chess game. Our chess game will have also a concept of an ID, right? I'm going to say chess game and the chess game ID. Chess game ID is a value object. If you don't know value object, again, feel free. It's available on the Microsoft because it's part of the concepts of domain-driven design. A value object, so class name. Then I like to close everything, right? Let's just say save. And then let's start off with the ID, right? Remember, I implemented all of this stuff before, as I mentioned. Now it's just a matter of just taking it and put it on this for this tutorial, and then we just go through it. So let me just fix these. Come on, this is Newtonsoft, and then this comes from one of my packages, which is value objects, and also the identities. Cool. Okay, this will be the concept of an ID in our chess game. So a chess game which is a chess game, which is like a chess game session ID. A chess game session will have a chess game session ID, right? And the ID uniquely identifies each session. Because remember, each session will house will house two players. So you could have like, if you're thinking about it, in this server, we could have two sessions running, which is each session will have its own two players. Okay. And then, so now let's go ahead and build the chess game session. Chess game session will have, right, let's just remove, oh, also the other thing, I like to remove these unnecessary using. Did I do it on this side? Yes, I did it on this other side. Okay, so now, as I explained before, a chess game session, it will have players, right? And the players will be limited to two, because remember, this is a chess game. Only two people get to play a chess game, so they play against each other, right? So we'll have players, and then we'll have the turn index. The turn index is what we're going to be using to identify whose turn is it to play chess. So remember, when one plays, so let's say player one plays, now the state of the session, it must now say, okay, it's player two's turn now to change. And there also must be rules where if player one attempts to play again when it's not their turn, the application or the server, it must tell the user, okay, wait, dude, it's not your turn. So that's what the turn index we're going to be using it for. And then the current player ID, it just basically returns an ID of whose turn is it. Okay, and then, but don't worry about the red stuff. And as we're building the domain, the red stuff will actually go away, because these are classes or entities, I may say, that I've implemented for this example, where wait, the one thing, my brain sometimes it's you see, that's why I took way too long to think about this, because I like to be prepared, but it's too complex for me to prepare. So now this thing is actually bothering me. So you will notice, if you knew on C#, when you create a new project, it comes with this attribute, which is nullable enabled, right? But then it moans in instances like this. And before, because I started coding, when was it? It was Visual Studio 2000. It was 2012 at the time. We never used to have this kind of like what's this? What do you call it? Alerts, if I might call it. And I see it's aligned green, and then it's gonna say non-nullable field, blah blah blah. It's quite annoying for me. So what I do is I remove this attribute. Remove. Move and remove. Okay. Now you will notice once you remove that attribute on your project, that thing goes away. See? There we go. Yeah. So as I was saying, a session will house it will house players, and each player will take turn. That's the goal of building this server. So we're building a server that allows players to take turns, right? And then, okay, so we've added the property, the index, which I've explained. We're going to use it to determine whose turn is it. And then this is just part of the information, or where, okay, look, who's the ID of the player, whose turn is it now to actually play. And then on the aggregate itself, we can have methods where we create a chess game, which is creating a new chess game that takes in players, and the players, there must be like two. And then we do some validation. Validation, it just checks. So this validation basically says, you can only, or you are only allowed to call create chess game if this particular instance of chess game session is new, like it doesn't exist on the database. Remember, this session, well, maybe it will make much more sense when you see it in practical. If we're creating afresh, it doesn't exist on the database. But if it exists on the database, like let's say you started the application and fetched a game session by ID, and then you try and attempt to call create chess game on that particular existing instance of chess game, this domain error will actually throw and tell you, okay, you can't do that because now this instance already exists on the database. So that's what this thing is here for. It's here to ensure that you only get to call this method when you are creating a new chess game instance to be stored in the database. And then once that is satisfied, then we can set the properties accordingly. And then emit an event. As I explained, we're going to do things like, we're going to do concepts like CQRS in this video. So that's when we perform an action, maybe something else we're going to be building in the future. I don't know yet as well. And we want to know, okay, when a chess game session is created, maybe we can do it like on the user interface, where we get to push notifications, maybe using Signal R. But that's another good thing is I can implement, maybe using Signal R. So what we would do is when we call this chess game session, it would emit an event that can be then transferred to the user interface to say, okay, whatever the notification is supposed to be, that a newly created chess game has been created, and here's the game, and now you two players can be able to play the game, something like that. Okay, that's what the emit will do. Would we emit an event once we've created the chess game? Same applies when we say play. So imagine with the play as well. So you only get to play in an instance that already exists. So this rule is there to actually ensure that when you call play, you are calling play in an instance that already exists. So meaning we've created a chess game that has two players already assigned that can be able to play the game. And whoever's turn is it to play the game, they can just play the game. And then, and also we implement another a rule, which is a specification that actually now enforces the rule of if player 1 and player 2 are playing chess together, okay? And then let's say initially it's player 1's turn to play. Player 1 makes a move, right? And then player 1, by the rules, is supposed to wait for player 2 to play the game. But if player 1 attempts to play again without player 2 playing, this rule will ensure that player 1 is inhibited from making that move. So, but you will see it as we go along with the rest of the tutorial, and then also update the current ID turn index. And whenever whenever a player makes a move or makes a play on the chess game, we wanna emit an event. Maybe that event gets to be a push notification to player 2's user interface to say, okay, player 1 has made his turn, now player 2 is your turn. So we can do stuff like that, okay? And yeah, that's pretty much it for the aggregate. So the aggregate has an ID. Now I want to go ahead and add another folder over here, which is called say entities. Entities. Okay. Entities. On our entities for now, we just only have player. Right? Player. No. Okay, I'll delete now. Let's just create a new one, right? Then go say player, and then I also need to create an ID for player, which will be say player ID. Cool. Let's delete this. Cool. Now let's take this code on the side. Remember, as I've mentioned, I've done this before. Now I'm just making a video to explain the concepts. Okay, let's remove all these unnecessary usings, clean up our code just to make it much more readable, right, and much more pleasant to the eye. And then on player, we want to copy that, then we paste this here, right? Remove, nice. Okay, so for now, you will see a player. It has an ID. We've already declared the ID for the player. And then we're just going to keep things simple. Anything we need to add, we'll add it as we go along, right? And then a player has a name. That's pretty much it. Player has a name. Now, if we go back to our chess game session, you will see as I'm adding the stuff, I also need to update this to say, okay, it uses this domain model, right? And then all the other rest stuff, like I did with the player, I'm doing it as we go along with the video. Okay, and then I also need, let's go ahead and build, okay, let's add the specifications. Let's add the specifications. So I like to place this command, which I should include in one of my packages, because I've realized I keep pasting this I keep pasting this functionality over and over in multiple projects. So it should sit in a common library that I can be able to use, which I will do probably in the near future, right? So this, you will see this aggregate is new. It just creates, so we have two specifications that actually ensures if like an aggregate is created, so if it already exists or if it doesn't exist, okay? And you will see as I do this is see aggregate specifications is now no errors, and then we have domain which uses our extensions. Okay, now we need to let's do this. So let's do the specifications next. Specifications. On the specifications for now we just only have the one rule which actually ensures each player, when a player makes a move, it's actually their turn to make the move. Otherwise, if it's not, it then throws a validation error back to the user interface to say, okay, hey dude, this is not your turn. That's what it does, and which you will see just now. We'll go through it. So what is this? So this is the rule I created. One of the many rules that we're still yet to add. Which is player turn specification. Player turn specification takes in a player ID, right? Once we have the player ID, we compare it against the chess game session. On the chess game session, what we do is this is the rule. So if on the session, on the chess game session, if current player ID, which is the current player who's supposed to make a turn, if that player ID is not equal to current player, throw a validation error that says it's not your turn. That's what it does. That's what it does. If this rule is not satisfied, you will see it throws a notification that say it's not your turn. That's simple as that. That's what that player turn specification actually does. So player turn specification is sits here. So we're gonna go see, and there we go. You see, we're cleaning up the stuff as we go along. And then next up, what we want to do is, okay, the next thing that's red is the events. So let's go ahead and create the folder for the events. And the events. So on the event, these are the two events that we want to implement. Chess game created. No, new folder, man. I'm used to saying new folder. Delete. So we have the folder already. We just need to paste. Just need to create this new class on. Boom. Created chess game event. Right. What we do with this event in the future, we'll just update as we go along. Especially played chess game, because I'll explain, because I don't want to put too much information or make the video not so I just want to focus on creating a chess game server that allows players to alternate turns as they play, and then anything else we'll just add along, right? So okay, say dot, right, play chess game. But let me just hint on chess game, on played chess game event. Another thing that we will add in the near future is, let me, just so I can talk about something that you guys see. You will see played chess game event. For now, we're just taking in the ID of the guy or the player that's made a move, right? But we would also want to know what that move was. Like, for instance, when you're playing a chess game, so what piece from where in the board did they move to where? Like stuff like that. Let's say maybe like the moving coordinates or stuff like that. So which is this event we will amend as we go along. Let's say maybe on the next video. When now, because for now the sole purpose is server, two players, they take turns, right? So we only focused on the player ID. But next up, it's going to be the player ID plus the move that they made, which is from what piece, from which location on the board to where on the board, and the validations that go along with that, which is that's why I don't want to talk about it now, because it's not for this video. But on the next one, the the parts that involve or entail the movement between like between players and the board and so forth will be discussed on the next video. Okay, but for now we're just going to concern ourselves with the player ID and the player ID, and then created chess game. Created chess game. It will concern about creating a new chess game session for who, which for the players actually. Right, you will see created event, which will take in the players of the players that are assigned on the chess game session. Right, cool. Let's go back to the chess game session just to make sure these are in the green. Right, nice. We're cleaning up. Now let's do this one. Actually, let's do the implementation first. Let's remove this load. Let's remove this load being red. Then I get to explain why do I have this lazy loader. I'll get to explain why. Actually, let me leave it for persistence, because it's to do when we're building persistence, this thing. And I'll show an example of when we don't have the, okay, wait. I'll get better. I'll get better. Because now my mind is, you know, when you're thinking about stuff, you're talking, but you're thinking about stuff. So now there's too much stuff that's in my mind, and I want to speak them all at the same time, and I'm trying to control myself just so I don't ruin this video. Because remember, as I'm doing this video, I'm learning as well. I'm learning. So, but I'll get better. So, okay, let's fix load, just so we don't have any errors. Let's fix load. So we want to build a folder, which is, let's see, extensions. And I promise you, man, like if you stick around with me on this and be patient, I promise you, you will enjoy this. You will enjoy this. It's quite a cool. If you are intrigued about software development, it's quite a cool thing to actually learn things in a practical way, right? Instead of just like learning the theory behind it, but when you get to build it, maybe let's say you're an employee for whatever company, and maybe you have a project that let's say maybe involves building something similar to this. You can use this as an example, right? But anyway, let's do this. Okay, let's remove all this unnecessary. Keep the code clean. Like, that's another thing I like to do. Keep the code clean, because remember, whatever you are building at the moment, in real life, right? Like if you're working in a software development, whether it's a private or public or whatever you're building today, tomorrow you're going to have to be responsible for maintaining it, supporting it, right? So if you write, let's say, like messy code, that's future headaches for you to come. And so I like to keep things clean, right? I like to keep things clean because I know in the future I'll have to come back to it. Whether business is going to come back and say, "Hey, Rondile, we need a new feature. Let's extend now okay. Thank you for building us this the system. Now we need more. Let's add more." When you build your projects in a much more like decent manner, it allows you to come back to it in the future and be able to do things easier than, let's say, not so clean code. Because not so clean code, if you've been around the software development industry, not so clean code, it's headache. It's a very much headache. So this POCO loading extension, okay, let me just explain, right? So you see on our aggregate, right, this chess game session will sit in its own table, right? Let me clear this red. It will sit in its own separate table, and the players object will sit in its own table. So we'll have two tables. The two tables will have a relationship with each other. So the relationship will be like, which is like database development stuff. chess game session can have 2 players, but each player belongs to one and only one session game. That's a relationship between the two. So now when we're loading this chess game session, which you will see when we, let's say, I'll do it in a practical way. When we, let's say, for whatever reason in our application, we want to get a game session, maybe a stored game session, we want to review it. So you query it from the database. When you return it, when we return it, we want it to return with the values of our players. But if we don't have this lazy loader, which is part of Entity Framework's implementation on how to come back with the stuff from the database, if we don't have this implementation, these players will always be null. I'll show you as an example. Like, you see, this is what I was going to. Ne? Stuff like this, you don't get to know up until you get to see them in practical, which that's my sole reason of creating this channel. So stuff like this, maybe someone doesn't know this, ne? But I'll show as a practical example. Players will always be null if we don't do this. It will always be null. So whenever we request this object from the database, it will come back with these properties like this current ID 10 IDX. This one is not going to be stored because it's not a get and a set. That's another thing you can see practical. But it will only come back with the current turn index, but players will always be null. Why will it always be null? Because of the thing that's implemented by Entity Framework by Microsoft, and which is because the player's name sits on a different table. Maybe at some point we don't need that information, but maybe we do. But for chess game, we do need it. So therefore, whenever we call this from the database, we want it to include as values the players as well that are assigned in this chess game session, which I will show in a practical way. Okay, I did a lot of talking there. But we're improving. I'll improve. Okay, so now what I want to do now is I just want to make sure all the stuff I've added at the moment, it still builds. I like to do this. Other people, they like to do things like create the whole entire project and then start building. I like to know my progress, like compilation-wise, if it still builds, and any errors that I need to fix, I can fix right now rather than fixing it later. So this is one of my, this is one of my patterns on how I do my development. See there, iService collection doesn't have, okay, I know what it is. It goes on the program because I'm not going to be using add open API. I don't need you. I don't need you as well. We'll get to this part when we cross this bridge, but I'll be adding Swagger to document my API. Okay, let's build again. Cool. So for now, we've managed to build an aggregate, which is a chess game session that houses 2 players, and each player must be able to make take a turn. And there's a rule that says if it's player 1's turn to play, but if it's player's 2 turn, player 1 cannot make a turn. We just did that. Okay. If you need for me to refresh, remember when we say play, we submit a player ID and then we run a rule to check is it this player's turn to actually play, and this rule is implemented in here. We do a comparison between the submitted player ID and what the session says, whose turn is it. Okay. Now let's go ahead and remove all of the. I like to keep things clean, because sometimes too much information causes you to lose your mind, right? So what's next is, okay, now what we want to do next is we want to include logic of if we want to get stuff from the database, which is you achieve it by using queries. So we want to implement queries. On implementing queries, so for now we're just only going to have one query. We'll just have one query at the moment, which will be responsible for getting a session, a chess game session by ID. Okay, so it's get chess game session, which will go to the database, grabs so you submit a query with the ID saying go grab me this chess game session with this particular ID. If it doesn't exist, so that's not an error. If something doesn't exist on the database, that's not an error. But otherwise, if it does exist, give me the value. Okay, let's just take this. Remember, I've implemented this stuff already, so we're just gonna be copying and pasting and just go through it. Okay, let's just do some cleanup. Okay, what am I seeing here? So we have a get chess game query and a get chess game query handler that handles this query. So this query will carry the chess ID, which is the criteria of the query, and then this executes it against the database by calling this find method. Okay, and actually, because okay, I did mention this I think initially on my video, né? Because I'm using my framework, né? And I know some of these things, it might look like it's magic, but actually it's implemented behind the scenes in one of my packages, which is these packages, actually these two packages here, that are responsible for my persistence, and the actual implementation of those is on entity framework. But I must do a video, which is a good idea. I must do a video that explains my framework. But anyway, for now, if you want to grab stuff from the database, this is how we do it. We create a query that implements EF core criteria domain query. We specify the object that we want to query against, and then what that object returns, right? So for now, we're just gonna, if I wanted to, I could have created like a model, any model. See, okay, I'll explain this because that thing keeps coming back to me again, where I'm trying to explain too much, and but anyway, entity EF core criteria. We want to perform this query against this chess game session, and then we want to return this. This could be any object, but I'll do a video to explain this, but it's going to be in the future, because remember, this is just my initial video, no? This can be anything. So the query will return me one object, right? What's the criteria? For now, we're just only passing in the ID. If I needed to add more properties, I'm just going to do it over here, which I will, as we go along, you'll get the chinks of it. You'll get the chinks of it. Okay. As the ID for now, we only have one criteria. We want to get a chess game session by passing in an ID. And then this query, once it's built, it will then be executed by this behind the scenes, by this handler, where now this handler takes that query, which is this query, the chess game query, and then performs a find, which will bring back one object from the database and then return it back to the calling user. Okay. That's what our query does. We pass in an ID and then go and execute against the database to get that record from the database. Cool. That's the query. And then what's next? Oh, we want to do commands. Okay, commands. All right. Let's close this. On our command, we have two commands. One that's responsible for creating a newly fresh chess game session, which is called create chess game command, right? This creates a new session which will take in whatever the new players are going to be to play this game. Okay. Remove unnecessary using. So create chess game takes in a chess game ID, a list of players, right? Which is, it's going to be 2. And we assign the players on the property players, but the property players, we're going to pass it to the aggregate, because remember, in our aggregate, we had a method there called create chess game that will take in players. So the players that we submit on this command will then be passed into the aggregate, perform and the action. If this fails for whatever reason, maybe it's a validation error, or let's say this, for whatever reason, it fails, we want to catch that exception, but then return something back to the user instead of just failing the whole entire application. Error handling is it's one of the most important things when you get to do development. But don't worry if you're new to software development. As you progress, okay, this class keeps disturbing me. As you progress in your journey, you'll get to understand a lot of these concepts. Because remember, this is for me. I've been doing this since 2015. That's 10 years. That's been a long time. So I can be able to do stuff like this where I can think, okay, where can I place my error handling? Okay, where can things go wrong? Like for instance, some other people can just be able, like, can just do this, something like this. But if this fails, nothing is going to be returned, or maybe the application is just going to bomb out. Whereas you can, it's okay, things can just bomb out, but make sure you cater for when things go wrong to say, okay, if something went wrong, the execution result, it failed, and why did it fail? We take the message from the exception and return it back, just so we can have a detailed explanation of what happened when we're performing an action such as creating a chess game. Another comment that we want to do now is when a chess game already exists, and now the players can be able to play, like take turns. So the play chess command is another thing that we need to add, which is .cs. Cool. Okay, then let's just do this. Boom. I wonder how much time. Okay, I'll see when I'm done recording how much time this copy and paste takes up. Because remember, I don't want this video to be too long. I want it to be short, right? Just so, because I can imagine, man, like too long videos can be boring sometimes. So I'm just trying to keep it short. But I'll review this video as I go along, and then on the next video I make improvement up until I'm a refined product. All right, play chess game. What it does is now when we're playing a chess game, you have to take into consideration, okay, when you're playing, where are you playing and who's playing? Where are we playing? We are playing on a chess game session. How do we identify a chess game session that we are playing to? By an ID, right? We want to submit that ID, right? And then who is playing? It's this player ID that's playing. That's what we're concerned about. But we're gonna change this on the next coming video, where now we get to implement the stuff that I was talking about, like, okay, the details of the moves. But for now, we just only concerned about the player making a move, right? So which is the player ID. That's the player ID, which then gets submitted on the aggregate play method, which is the player ID, which internally will do a validation to check if is it this player's turn to play this chess game. If so, okay, cool, return a success. But otherwise, if it's not, it will come back with the a failed validation, and then we catch that validation and then send back a notification saying, okay, this command, it failed because X, Y, and Z. Okay, that's our command. Okay. Okay, I think that's pretty much it on the domain side, right? So okay, now that we have our domain, right? Another thing that's quite important, right? How can I explain this? And it's quite important. It's one of the quite important concepts when it comes to application architecture. So I want to explain the concept behind what I call applications. So if you notice, inside the domain model, we've been building stuff as modulars, right? It's like think about it. It's like think about building a wall. You build a wall by bricks, right? So if you think of the commands and the queries and the events and so forth as bricks, to make up a wall, you combine them, right? And then they make up that wall. I hope I'm making sense with this example. So in applications, we will create now a composition layer, if I may call it, where if, let's say maybe the requirement is, I'm trying to think of a way to explain this. Let's say there's a requirement as part of our chess game. I'm just going to use this name. You create a chess game, but creating the chess game, you also want to, let's say, create a chess game, and then you also want to, let's say, query for some other information and then return it back once you've created this. But it's going to make much more example. But this one, it's going to be a composition of putting together these actions to implement a business requirement, right? And okay, a chess game, it doesn't provide an example of this. Okay, I'll give you an example like this. Now, imagine you're building an employee or an HR system, right? So now in your user interface, you want to add a new employee. Let's say this is a newly hired employee. You want to add a new employee, right? So now if you think about the domain model for an employee HR type of system, you can have a command where you create a new employee. You can have a command where you get to query for employees to see how many employees do you have. It could be 300, it could be 1,000, right? But on the user interface, once you create that new employee, you want the interface to update now with the newly added record. So you get to say create this employee, but then once we've created successfully, then query against the database so you can return me back now the new list and that includes the newly created user and return it back to the database. That composition of a command as well as a query to perform a business requirement, you do it in this layer called applications. How do you do it? So create a new, let's add these two folders. So abstract, right? And then inside, we're also going to add, let's say, business logic. Business logic, all right? So inside here, we will have an interface that houses iChess game service. I'm just going to call it iChess game service, right? Instance of iChess game service will be these three actions: create me a new chess game, get me a game by ID, or play and play the game, right? Remove this on, right? Then what we want to do is we want to implement this service. When we implement the service, we implement it inside business logic, right? Now, I'm so used to creating a new folder, right? Add a new item. Okay, chess game service. And the business logic inside will be looking something like this. Just move anything we don't need. Cool. So what are we seeing here? Remember, I have an interface that defines the methods or the implementation that we want to implement, which is create me a new chess game, get the game by ID, play the game, right? And then the implementation of those is we get to, okay, we'll come back to that. So this is create new game, which a create new game calls the command that we created previously, which is called create chess game, that takes in players and create. Once we have that, once we have the command, then we call command bus to publish that command, which will then be executed against the database and save the chess game. Same applies with the game ID. We create a new query with the information that we just submitted, and then call the processor, which is query processor, which will go against the database to execute that criteria, which is the ID, come back with the result and say success. Whether it didn't, so let's say if we query by ID but we come back with nothing, that's not a failure, that's a success. That means it went to the database and then it checked on the database that whatever record was supposed to be with that ID, it doesn't exist. The only time you get to experience an error is when you're querying against the database and then something goes wrong. Maybe the database is not available. Maybe it's a network database, or maybe it's a build, or I don't know, like a code error or whatsoever. That's going to be a failure, and I'll show you where I get to cater for that. And then so query and then return a success. Whenever we go to the database and come back successfully, that's a success. Okay. Play game, same applies. We call the command that plays the game. We pass in the game ID as well as the player on which board they're playing on, and then submit to the command bus. The command bus is there to deal with commands. The query processor is there to deal with queries. Okay. Again, these concepts, I'll do a video explaining on how to use this framework that I'm using behind the scenes. And what's nice about the framework is now, I'm not sure if you guys gonna notice now, is I don't focus too much on the technical implementation of this microservice or the API. I only get to focus on the business logic, and then the technical implementation. I've already done it, you know, using the NuGet packages that are created that are stored on NuGet, and then I get to use them. So I don't have to think now too much. That's another thing or an important concept when it comes to using frameworks, you know, or common code is it takes away the technical it takes away the technical details and get to focus on implementing the business requirements, because right now my mind is so centric that in the fact that I'm building a chess game, not saying, okay, hey, I need to build a framework to interact with the database. How do I execute queries? How do I execute commands? How do I blah? No, we just using the framework and only get to focus on the business requirements, just as you can see on the API. Okay, and then okay, now we have the application. So we have the application, we have the domain, and then another thing I need to add is how is this whole project actually gonna be composed, right? So let's add a new extension. Right, it's an extension. Gonna call it game class, and you will see this when we get to the API, where I get to call, where I say configure domain, configured domain. Configured domain is we using reflection. By using reflection, we get to pick up the commands that are available on the API, the events that are available on the API, the queries that are there, and so forth. So we just need to add all of this stuff. I have to do this one by one. Visual Studio, come on, should have just had an option to include all of these usings. Nice. Remove unnecessary ones to keep the code clean. This configure domain, you will see when we get to program. This is where on the start of the API, we're gonna call this, which is part of the composition of the API. And I think that's pretty much it on the API side. Yes, that's pretty much it. Now let's go over to persistence. Persistence, keep it clean as well. Let's close all of this. Persistence, we need chess game context. Chess game context, if you know Entity Framework has a concept of context. This is what is used. It's like, this is like your database version, but in C#. So context, it's like your database, okay? It represents your database, right? Chess game context, which is, again, if you're not quite familiar with Entity Framework, especially this this API, I get to implement it using code first approach, because there's two approaches on Entity Framework. There's database first approach, there's code first approach. Code first approach is we create, like as you will see when we're running the solution, we will create our database from scratch using a database, using our code. So database first approach means you start building the database first. Okay, I hope that doesn't mess up the thought. So database first approach involves having a database first, and then you build the code based on the database, okay? So any changes that you make, let's say maybe you add a new stored procedure on the database, you would have to include it on this side using what's this, not migrations, what is it called? What is that thing called again? Never mind. Okay, let's build our context factory. This builds our chess game context. That's a factory. Right, chess game context factory. And also, again, don't worry about following along with this. Once we have finished this video, this code will be available to download on the GitHub, so you can be able to clone it on your end and get to experience with it and see how all of the stuff is implemented. So, right, remove unusings. Okay, we over here when we're saying chess game context factory, ne, we want to check. So because it's gonna be actually it's a real world thing. Actually, this thing, ne, as like software like as experienced software developers would tell you, in a typical real world exam, real world system, ne, we have multiple environments. We have a development environment, QA environment, sometimes UAT environment, as well as production environment. So development is what's used by us as developers to to develop the whatever the product that we're developing or the system that we're developing, and then the QA side it's used for once now we've done, let's say, our sprint, and now it's time for the systems analyst or the testers, automation testers, or whatever, to test the stuff they test on QA. And if everything is satisfactory, and then you get to involve the users, which is UAT, user for something testing, where we get to involve the users now to test before we deploy the stuff in production. So typically, we on the real world environment, we have 4 environments: dev, QA, UAT, as well as production. Okay, so that's what we were doing over here, and each environment will have its own different database. So what this does is it looks at the environment, and then before it builds the context, it wants to know, okay, on which database should the context be based on. This environment would actually tell, okay, if we're on dev environment, take the app settings dot whatever the environment is, and then build that context, and then return us back the newly created context with the connected database, if that makes sense. I need to get better with this. Well, and yeah, this one, the provider, it's used by code first approach, and it's also responsible for building up the context of our database. So there we go. Move usings. Okay. Then talking about code first approach, I'm thinking of a way to explain this one, right? So this is quite an important one, right? And I love the way I came up in implementing code first approach, right? Because code first approach, if you are not careful with it, it can mess up your code, and it can be too clunky, right? So because I like simple things, I came up with this simple way of implementing code first approach, right? Which, as you will see just now, I want to explain this one, but I wanna be more specific about this one. So, see over here, as little as this is, I can imagine to someone else this is and someone who doesn't know code first approach, how ugly code first approach can get. With this approach, it sort of makes things easier to read and also to maintain in the future, right? Because this defines the relationship between tables in a database. So I don't want to specifically make it about chess game session as well as player, right? This defines the relationship our tables will have between each other, right? And then there are things, because remember, as devs, we get to create objects in our domain that we need to map, right? So there's mapping, right? This is mapping, and then there's a relationship, right? So this mapping you see over here, I'm just going to explain bit by bit. It says on this entity chess game session, for the property called ID, because the property ID is a custom type, right? The custom type is called chess game ID. We want, when we go to the database to query for chess game session, we always want to have a value for the ID. But Entity Framework doesn't know how to decode your custom ID. So basically here, we tell Entity Framework, this is how you decode the ID, right? So this ID is a custom type, which is called chess game session ID. And then when we say has conversion, which is a single value object identity value object converter. It takes into consideration, but it takes it's this object's concern to convert this to and from the database, if I'm making sense. To and from the database. So when you're saving chess game session, it will only save the value that sits inside chess game session ID. And if you want to retrieve the value, because you will see on the database, you will only get to see the value on chess game session, but you're not going to see all of this other stuff that sits inside Amos's identity, because identity is it's quite a large object. I'm not sure if I'm making sense, but okay, but we'll explain it. But in simple terms, take this from me for now. This converts this ID to a value that we can store on the database, as well as when we query from the database now to, let's say, our program, we can reconstruct that chess game session ID with this convert over here. Same applies for player. That ID is a custom type, and this is responsible for converting it to and from the database, player ID. And then this is another one that's quite important. It describes the relationship between player and chess game session. So we're saying here, entity player has one, meaning it belongs to one session ID. So our rules in our chess games will say, I as player ID so can't be in two sessions at the same time, right? If I'm assigned to a session, that same ID mustn't exist to another session, right? That's what it means. Entity player belongs to one session, chess game session. But chess game session can have many players. But in our instance, it can have two, right? But many starts from two, right? So we have entity player belongs to one and only one chess game session, but chess game session can have multiple players, which is two players at minimum. That's the relationship. So this is the mapping, and then this is the relationship between our two tables. Okay. Okay, that's it on the database side. But there's another important thing. If you know Code-First approach, we build things by migrations. But I can't build the migration now because I still need to finish the API, because this API, it needs to be done before I can build the migrations, because it will use the app settings that we have on the API. So let's go ahead and build the API. Okay, let's start with program. On program, I want to add my stuff. Okay, let's close all of this other stuff here. Program, let's just add all of this stuff, and then we'll build all of the stuff that's failing. Okay. Okay, we'll be using AutoMapper to map stuff. AutoMapper, if you don't know AutoMapper, it's quite a simple thing, but it will make much more sense when you get to implement it. And then on our controllers, we want to use Newtonsoft. That's what we do over here. We're adding Newtonsoft instead of the default serializer, which is, I think, it's system.text.serialize or something like that. But I don't want to use that one. I want to use Newtonsoft. That's what I'm doing over here. And then you will see here, I removed OpenAPI. That was added by default by Microsoft, because I don't want to use that to document my API. I want to use Swagger because I'm quite used to using Swagger. Swagger is quite easy. You will see when I'm running the API. And then if you remember configure domain is this little method over here that we told that actually tells the API how to compose our domain model. But for whatever reason, sometimes some API doesn't do this, so I have to do this manually. So I say using that extension, right? You will see now it's available. And then configure persistence, for whatever reason it's available. And then okay, we'll get to that one. So okay, let's go ahead and build the rest of the stuff that's missing. Where do we start? Okay, let's just start with the models. So what I want to do is I want to build the models first. So Let's add a new folder, which will be models. This will house, because remember, on our API, we'll be mainly making requests to the API and expecting responses back. So in models, what we're going to be housing is our request models as well as our response models. So we have create game request. Okay, actually, I have an abstract. And for now, we only have response model. Let's just build the response model. Response model, right? No, don't build. And then we want to add create game request, because when we say create me a new session, we want to send a request to our API, which will be carried by this object. So our request will be carried by this object, and then it looks something like this. Looks something like this. Our request will carry players that we want to add to our chess game session. Okay, and then we'll get to this one, but I don't want to explain it now, but we'll get to it. And then let's say get create game. So we have a request for create game, and then we'll have a response for create game. Okay, we have a response for create game, which looks something like this. Okay, so when we're creating a game, we expect to get in return the game session ID. Okay, but what would happen if something went wrong? We want to know when something has went wrong, right? How do we carry that information? You will see I inherit on response model. What does response model look like? Response model looks like this. It has a flag that says our response was success or it was a failure. And if it was a failure, we'll have errors. And each error has a description of what happened. So we carry all the instead of carrying all the other properties that we don't need, we're only interested to know what went wrong. If it's a validation error, it will be carried out by this text property. So that's how it looks like. So our response will have a game ID. If it was successful, cool, we get our game ID. But if it wasn't successful, we won't get our game ID, and we want to know the information which will be carried by errors, which, okay, what was the result of, okay, or what was the cause of not getting back the game ID, okay? That's what game response looks like. And then also when we say get game, we get game, it's quite simple. I don't even need to create a request for, like, we're just passing in the ID for that. But there's actually, to keep things uniform, I should have just created a new request. But okay, we'll just make that improvement on the next video. Get game response, you will see these models when we use them on the API. But I'm building them for now because the next part we're going to be doing is building the API. So on get game response, we get the game ID as well as the current player turn, like whose turn is it to play the game. And again, if we were requesting for the session or the game session, and we didn't get the information that we were expecting, we want to know what happened. That information will be carried by errors, same as with create game response, with the one we just did earlier on. And then lastly, we'll choose play game. Play game. Right. Boom. Play game. For now, it's quite simple. For now, for the sole purpose of this initial, like, this is our sprint. Remember, this is our sprint. This is like we're developing this project for like 2 weeks, right? And then our business or our product owner will want to see our first initial build, which is a server that runs, that can allow players to take turns. And then once we're happy with that, and then we move on to the next one. So remember that our purpose, sole focus on this project now is to build a game server that can allow players to take turns playing. Yeah? So, but this object will be extended as we go along. So when we say play game response, for now, we're only interested in if it was a success, and if it was not a success, what was the cause? That those errors will be carried out with on the response model. Okay, those are the only models that we have on the system, right? Which is create game, game response, get game, as well as play game. Okay, now what I want to do is I want to add a new controller. This new controller, we want to name it chess game server. All right, so it's an empty controller. This game server. Right, it's an empty controller. And then let's just copy and paste all of this stuff here. Boom. Nice. No errors. Cool. So what's going on here? These are the endpoints that we'll be exposing in our API. See here. These are endpoints we'll be exposing on our API. So on our API, which soon we're going to run the solution so you can see what an endpoint is if you're not quite familiar with what an API is. So we'll have 3 endpoints. An endpoint where when it's called, it creates a game session, assigning the players on the session. And then another one would be get game. And then another one would be play the game. Play the game when we pass in the game ID and the player ID. Okay. And then it would execute against our service that we created on the domain side, which is on the applications, where it gets to call the relevant functions like create new game, get game by ID, and then say play game. Okay. And also beauty thing is, okay, maybe I don't even need to explain this, but we're using dependency injection to get objects into our controller. Like this is constructor injection. So these services, which we are going to register on, but we'll get to this part, which is where we say configure application infrastructure. This is where we will be registering services that are going to be used in our API. We would register them to the dependency injection, which is the iService collection, and then be internally by Microsoft, which are the clever guys. They've implemented constructor injection so that when this controller is being created, these instances will be available for us and we get to use it. It's quite nice. It makes things easy and quite neat. So those are the endpoints on our application. And then also the other part is I need to do is, okay, let's do the registration of our services that we're going to be using to on our dependency injection. And let's go ahead and create an extension. I like to create extensions just so you will see, if you haven't seen yet, a lot of people, they like to abuse this page. I don't know why, this program page. They put all the services here, and then you find this file is like 1,000 lines. You don't have to do that, man. You can just do things in a much more neat way, which is the way I'm doing it now. So just write an extension method. You can just do it with an extension method where you get to, at least, in the future, if I need to add new services, right, on my dependency injection, I can just jump into this method and it will show me only and only that part of the dependency injection, not to see a whole line of thousands. So do an extension method, which is chess game server extensions. Oh, this code is so small. I'm not used to it. Chess game server extensions, and the chess game server extensions is where we get to register our services. You see, that's it. See, so now in the future, if I'm maintaining this program or I need to do anything, if I need to modify this, I don't have to worry about looking at thousands of lines of code. I can just go inside application infrastructure and add or remove whatever I need to remove, whatever I need to add or remove inside here. That's it. That's it. Keep things simple, keep things clean. Okay, and then nearly there, nearly there, nearly there. We actually close into running this and seeing it run for the first time. Okay. And then last but not least, we need to build our mapping. Okay. Oh, let me go back. Let me go back to the controller. You will see on the controller, you see this map over here. So this create result. Né? If you look at create result, right, our execution result, it has, okay, this is the contract, né? But it's a complex property that involves some other details that I'm not too concerned about when calling an endpoint. When calling an endpoint, for instance, create game, as the consumer of create game, I only want to know if my request went through successfully, and if it went through successfully, I'm only interested in seeing the game ID, right? And if I don't get the game ID, I only just want to see the detail of the error, which is the text of the error. Okay, to say you didn't get the ID because it's not you did something wrong. Okay, not to see all the other information that's not relevant. So with a mapper, you can be able to write a mapping that takes a complex object and then deduce it down to a few properties of concern when calling the endpoint. That's what this thing is doing. And how do you deduce a complex object to a simple object? You get to write mapping, which is the part that we're going to get to, which is AutoMapper. If you're not quite familiar with AutoMapper, documentation is available online. So we're using AutoMapper. So I'm just going to call it mapping, and then I'm just going to call it model mapping. So on the model mapping, this is where we get to define now the logic of deducing a complex object to a simple object. Okay. So what do I mean? What am I talking about? So if you're not quite familiar with it, this is what I'm talking about here. So profile implement is an AutoMapper class that's implemented by AutoMapper. And then look here. So we're saying create a map. I'm just gonna like that thing of deducing a complex object to a simple object. So what we're saying is here, see, message is a complex property that has all of these properties. Now imagine you're calling an endpoint and you get all of these properties in return, but the only one property you're actually interested in is the text, is the message, right? So what we're doing here is we're saying, create me a map that takes message and then creates error response model. Error response model is this as the string text. So what we're saying here is for the member on error response model text, map from our our source object, which is message, take text from that. And for error response, we have public string text populated instead of seeing too many properties that we don't need. So that's what it does, is it deduces a complex object to a simple object of your choice. You define that, okay, what do I need from this object, and then put it on this other object. Same applies with the other ones. Chess game ID, we're only interested with the value. So when I convert this chess game session ID to a string, that's from the versus the ID, we want the value. That's it. Same applies for these ones. It's quite simple, man. It's very simple. You just define what properties do you need for that particular conversion. That's it. So what it does is for our responses, we use AutoMapper for that. So you will see on our endpoint, we execute towards our domain. Our domain comes back with the result. We deduce that result to only the interested properties for our response model. Once we have our response model, we can then return back either an okay, let's say our performing the action was successful on the domain, we return an OK result with the designated response model. Otherwise, if it wasn't successful, just say it's a bad request and why was it a bad request. Same applies with the other endpoints. Perform an action against the domain, deduce the result from the domain, and then return the result. Same applies. Action against the database, the domain, deduce the result to designated response model, and then return the response. Simple. Okay. What else? What else? What else? Okay, one more. Okay, wait. Let's just check before, because I think we're nearly done here now. Okay, now we have the model mapping, so we just need to include this using statement over here. And one more thing we need to do, yeah, because now we're gonna building now. So now what we're gonna do next now is make sure our migrations they build successfully, and something I was gonna do. What was I gonna do? Oh, I wanna go to. Remember, this is development, right? So on our app settings, we want to go to. We don't want to add the settings for our, because now we're going to add the configuration to our database, right? So we're going to go to app settings to development. This is our development database, and then we're going to add a new property there called data connection. Data connection, because I have SQL Express installed. So we're basically saying on our SQL Express, create, or whatever the name of the database is going to be ChessDB. Let's just call it Chess Server, because this is a server we're building, right? Chess Server DB, and all this stuff is just by default. Okay, so we're going to be using this to connect to our database. Okay, now the beauty about code first approach is it's going to be like magic. Okay? So now what I'm going to do is let's just copy this, yeah, and go to, this is SQL Server Management Studio, where you get to, I use this as a tool to inspect my relational databases, right? So I'm just gonna say connect, and then connect would be connecting to local express, Windows authentication, and then connect. So over here, we're going to our local host, which is SQL Server. Why are you taking forever? You should not be taking forever. You should not be taking forever. You should not. You should not. No, wait, something's wrong. What did I do? No, cancel. No. Oh, okay, I see why. It was because of the 2 slashes. But still, it shouldn't be taking too long. Don't tell me I need to install again SQL Server. What happened? Okay, let's figure this out. Part of software development, you get to deal with stuff like this. So, okay, another way of, because I did install SQL Server. I wonder, what did I do now? Okay, let's figure it out. Let's figure it out. MS local DB. Okay, let's use this one. Let's use this one. SQL Express, I probably need to install the SQL Express, or because I restarted my machine, the instance, and I don't have time to figure that out, but it's fine. And let's just do this. Name, connect. Nice. That will work as well. So what we want to do is, you see here, if you notice, this is what we're going to be doing now. You see, on databases, we have no database whatsoever. The beauty about code first approach, they can create it can create our database for us. How do we do it? So let's just change this to local DB, MSQ local, blah, 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 whatever that thing is. So now, if we go to tools, NuGet Package Manager, go to console, manage package console, make sure this project on properties is set as startup. That's important. Otherwise, this thing, code first approach is not going to work. Your API with the configuration, it must be set as the startup, which should be this thing. I swear this thing changes more often. That property usually sits at the top. Is it debug? In application? Which one is it? Oh, actually, stop this. There's a property on the menu that says set a startup project. Just click set a startup project and make sure it's highlighted in bold font. And then when you go on NuGet Package Manager console, and then you choose your persistence, right? And then now what I want you guys to focus on, which is the beauty of this thing. You see on our persistence library, we have only one folder, but there's going to be a new folder now that's going to be added by Entity Framework. If I configured everything right, if we run a command called add migration, give it a name, let's say it's our initial migration, which is I'm going to say add migration init, and then I say press enter. It should build the project and then build our migration. So if you notice here on the right side, under mappings, there's going to be a new folder that's going to be added by Entity Framework, which is called migrations, which is responsible for the creation of our database. Build failed. Why did you fail? Okay, I think I didn't build my solution. Let's see. What is it moaning about? Let's see. What are you moaning about? What are you moaning about? Oh, okay. It's this using statement. No, clean man. Let's say build. Build up. Build up. So, if all goes well right now, we're going to build the API, build the database, and then we're going to run the API for the first time and then perform some tests in it. And then on the tests, what we want to see is we can create a game session and that game session can be stored in the database. And then we can have 2 players assigned to the game session. And between those 2 players, they can take turns between each other, which is we're ensuring if our rule to check if is it this player's turn to play actually works. If yes, successful, we're going to get a successful execution of our endpoint. If no, we're going to get a validation result that's going to say not your turn. Okay. So let's go back. Okay, so everything looks all good right now. Let's go back to and then I'll just press up, which will say add migration, which the name of the migration is going to be init. Press enter. It builds the solution in itself. It says build succeeded. Now it's going to build my migration under mappings. There we go. See, if you look under migrations name, and also another thing, if you're quite new with what's this code first approach name, never modify this file by yourself. Always never modify this file by yourself. Always use add migration to actually modify which I will show in subsequent videos as we build the database along. We're going to be adding migrations. Never touch this file by yourself. So this creates some sort of like a schema on how to create our database. And by doing this, mind you, there's no database yet. So if you go look here, and if we refresh this, there's nothing, right? How do we then get our database to be created by Entity Framework? So because we've created the migration now and everything is all well, there's another command you need to run, which is called update database. And then I like to say verbose. Verbose basically says, okay, when Entity Framework is running that command, it shows me the information on the console. So you will see it's going to do some magic. Now what it's doing is it's creating the database now it's creating the database, writing the tables and so forth. Now it's done. Now if we go back to our SQL Server Management Studio, and if we refresh, we should see a newly created database. The newly created database, it should have our two entities that we defined. Oh, no diagram. No, I don't want to create diagram. Our new tables that we defined. Table is just used by Entity Framework. This table is used by Entity Framework to manage the current version that built the database, which the current version of Microservices that built the database. You don't have to concern yourself with this one. But again, don't ever touch this this table. So we have our two entities, chess game session. If we open our chess game session, you will see it has its own properties. Come on. There's our properties. We have our ID, the current turn index, as well as the version of the of our chess game session, and our player table. There's it. See, I didn't even need to create. That's what I like about a code first approach. It's quite fast for us, for me as a software developer. If I'm creating something that requires a database, I can just write code and define the relationships in my code, and then let the code build the database for me. That's fast development. Some people like it, some people don't. You will choose your own. You'll choose your own your own devil. Player as an ID, name of the name of the player, and the relationship. This chess game session ID is the relationship between this player and which and which chess game session they belong to. Okay. Now, what we're gonna do is, since everything is all well, we built the domain, we built the persistence, we've built the API. Let's now just gun this thing and run it for the first time and see the API and its endpoints. Okay. I just want to make sure I did everything. So we have the database. That's cool. I think. Okay. Let's just gun it. So if I run this, it should automatically open an API page with my endpoints. Okay, let's see. What is this? Okay, it's fine. What we can do is, I'll figure that why it's not popping up again. But basically, we can see that our API is running on HTTPS localhost 7280. So what we can do is can open up our browser and just type localhost, right? Let's remove all of this other stuff. What was that endpoint? 7280. 7280. Then forward slash. Actually, let's just do this, and then I'll change this port because it should be swagger dot blah 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 72280. Right. Now it's going to show our endpoints. And why do I like Swagger so much? Swagger is quite simple. I love it. Swagger and Postman are the best. So what I can do here is, see, I have create post. This creates a game session. I have chess game ID, which gets the chess game session by ID, and a player can invoke play to say, okay, I'm making a move now on the chess game. So these are the three endpoints. So if we say, that's one of the things I like about Postman is I can I can send requests on this nice user interface over here. So on our create, I can click with cancel, which is try out, which now enables me to edit this this part of the UI, and then over here I can just put just copy this, and then on the name, you see this doesn't even have to be formatted, but I'm going to do it anyway. Wait, what did I do? Okay, let's just leave it. So I'm just going to say player 1, that's the name of player 1, and player 2. Okay, so I'm saying create me And also, just to show you that it works, ne, I'm gonna refresh query. Ne? See, nothing comes out. And then on the player side, nothing comes out. Oh no, nothing comes out. Okay. Now, if I run this command, it should successfully create the records in the database for me, and then comes back with a success result. Let's see, inspect. Cool. So you will see we ran create endpoint with this payload, and then it went to the system, created the chess game, which goes with this ID, chess game ID, right? And it tells us it was successful, and we have no errors, and that's the result we were actually looking for. So how do we then verify if we are querying the stuff from the database? Does it actually work? Let's go to the get endpoint, and then say try out, and then paste that ID, and then say execute. It comes back with the result. Now this result is saying for this chess game session, the current player whose turn is it to play now goes by this ID. Okay, goes by this ID. Okay, and then okay, the query was successful. So now, okay, before we actually make a play process, we invoke play endpoint. What we want to do is I want to verify to you that on chess game session, if we run this query, you will see records now on our table. And if we go to the player on the player table, we run this. We have 2 players now assigned into this one. You see this chess game ID, it's one chess game ID for these 2 particular players, right? And then let's see on the result, what is the API saying? The API is saying for this game ID, the player who's supposed to be playing is, I'm just only going to read the last 3, it's FAE, right? I want to show you now if the player, it's not their turn to play, what's going to happen. No. Go back. I want this one. So let's go to play. Now we're going to invoke the play, right? So play, try out. Now we're saying, okay, let's just put this here. And then we need this game ID. Copy that game ID. On this game ID, remember this player is not their turn to play the game. Okay, so what we expect now when we say execute, the server should tell us, my guy, it's not your turn to play the game. So there, let's go. Now you can see we executed the endpoint against our API. It came back with the result, and the result is an error, which is a response code of 400, which is bad request. The success, it's saying it is false, but it came back with errors. And what are the errors? Player turn specification, it tells me, okay, the rule that fail is player turn specification is not satisfied because of not your turn. Okay, that's not a good way to learn it, but anyway, you get the point. It comes back with the validation result that tells you, okay, why it didn't work out. So now, because we can invoke a failed execution, let's see when we get to invoke now the actual player's turn, the actual player whose turn is it to play. So if we go now, change this whole thing and paste it here. Let's see what has come back. Take your time, take your time. And why is it taking time? It shouldn't be taking time. Why is it taking time? Okay. Looks like something failed for whatever reason. Violation of primary key constraint, cannot insert duplicate chess game session object, blah, blah. No. Okay, let's figure out. That's part of development, right? Why is it doing this? Because it didn't do this before, unless I've made a mistake. Okay, let's figure out. This is part of development anyway, part of development. So The error was, okay, sorry. The error was somewhere here. It's gonna say the duplicate key chess game cannot insert duplicate key into chess game. Yeah, but you're not supposed to create. What is it? What is this thing doing? Let's go to play. Maybe there's something I did there. Play game. Okay. Good. Okay. No man, I feel like let's run this again. Nothing is wrong here. Sometimes things like this happen. It's quite normal. It's quite normal. Yes, you see, there's nothing here. Okay. Let's see. Refresh this. Okay. Now we're gonna call this game ID. We're gonna do it again. I just want to see something. So this is chess game. This is the game we want. This ID. Paste it right over here. And whose turn is it? It's AE. It was AE. So it's this guy's turn to play. Okay. I want to see something here. Oh, I know why. I know why. I know why. You know why? It's those double quotes. I shouldn't include those double quotes inside here. So let's go execute. It's those double quotes. So you will see. Hold on. Dude, are you kidding me? No. Okay. Okay, went through successfully, right? So it is this player's turn. So now, if I execute this, remember, it was this player's turn previously. No? Now, when I execute again with the same ID, it should come back with a validation error. You see, there you go, right? It's not this player's turn, but that bug interests me because I didn't pick it up initially. No? I just want to try this again. So now, what I'm gonna do is I'm gonna play. Now, because it's this player's turn now to play, I want to see something. If I can replicate this bug, because that was a bug. Right? Execute. Okay, it went through successfully. Now it tells software development for you. See, now that bug is gone. But we'll figure it out. But essentially, imagine we built an API that can create a game session, assign to that game session 2 players that are going to be playing the chess game, and then we can get, if let's say for whatever reason in our system we want to get the state of the game, we can get that game session by querying it using ID, and then it's going to bring us a bunch of information, right? Which we're going to extend on with the next subsequent videos. And then we have an endpoint that each player can call to make a play, right? The next important things now we're going to have to consider, which is going to be part of the next video, is because we at the end of this video now. Next thing we're going to be more concerned with, especially with the play partner, is things like, because this is going to be a server, we have to consider race conditions. If you don't know what a race condition is, this API is quite open in the fact that multiple requests can go simultaneously at the same time, right? So therefore things can go wrong. So like player ID, let's say player one, a malicious user can, or maybe someone who wants to create a DOS attack, they can send way too many requests into that one particular endpoint, and that can crash our system or or causes race conditions. We can create inconsistencies in our data. So how then do we cater for that? We're going to implement logs on the next video. We've reached the end of this video. So we've successfully implemented the phase one of our project, which is create a game server that allows two players to take turns when playing. Next part would be to implement things like, let's say the board, but I'll plan it out just to see, okay, what's the next part now, where we get to implement the board now of the chess, like the chessboard. Because remember, when you're playing a chess game, you're playing against the board. The board is like an 8x8 grid with two-dimensional grid, and then that two-dimensional grid gets populated by pieces like the pawn, the knight, the king, the queen, and so forth, the rooks, and so forth. And get to consider the rules of the pieces. We're going to implement those rules piece by piece, and also, if you've reached the end of this video and you're quite interested in the stuff that I'm building, talk to me. Send me comments, like especially when it comes to the user interface. Which user interface or platform should we use? Should we use Razor to build the user interface? Should we use React? Should we use Vue? What would you like to see? That's the whole point of this this channel. And also, if maybe there's some mistakes or maybe some concepts that maybe I'm missing out, or maybe you guys are more educated than me on it, feel free to share it, just so we can be able to, because remember, this is not a one-way educational video. It's a two-way. You learn something from me, I learn something from you. That's the whole point. I hope you get to enjoy this video. I get to see you on another one, and don't forget to subscribe if you enjoy my channel. Don't forget to subscribe and like my channel. Thank you so much. Appreciate it.